Hey everybody, this is Alex Merced from alexmercedcoder.com, and this video is basically everything you'd ever want to know about JavaScript functions. Okay, so this is going to be maybe a longer video. We'll see how long this takes. I'm hoping we keep it less than an hour, but there's a lot I'd like to cover. This is for everyone who just really wanted to know everything about JavaScript functions. So first, let's just start off with the syntax. If you hear my bird in the background, I have a cockatiel. It's there. Yeah. Okay. So there are three ways to write a function. So let's talk about the original method. So the original method of writing functions. Okay. So in this case, the way it would work is you'd write the word keyword function, the name of the function. So we'll just say myfunc1, and then you'd put parentheses. We'll talk more about the parentheses later. And then you would just put in curly brackets. And we'll just do something really simple. And again, I'm assuming you know some basic JavaScript. So I'm assuming you know what I'm doing when I say console log hello world. If not, please go watch my introductory JavaScript videos. So that's what this function does. So this is a function definition. I defined a function. So this basically says we're defining a function, and it is stored in this name space called myfunc1. And then I can, so this is again defining the function. So this is the function definition. And then I can invoke the function, which means I can actually use the function. Because what a function is really just a bundle of code. It's a bundle of code that you've strapped to a name so you can use it whenever you want. So I'm saying, hey, I don't want to have to type all this out again. So I'm going to tie it to this name, myfunc1, so I can use it as many times as I want. So here we go, myfunc1. And then you have to use the parentheses to invoke the function. Okay, so this is, I'm invoking the function. And I can do it multiple times. Myfunc1, I'll do it again. And now if I go to the terminal, let's open up the terminal, and I do node test.js. See, hello world, hello world. I did it twice, and then I have to type in console.log hello world twice. So we defined a function. Now the problem with this original method is that one, it has a feature called hoisting. What that means is that when you run your JavaScript file, it's going to look through your file for any use of the function keyword first, read those function definitions, and then load them into your memory. So one, you're using up a whole lot of memory right off the get-go. So if you're running a large script with a lot of functions, that's all being loaded up into memory before anything gets done. Okay, it does that first. Now, the slight benefit of that is I can actually invoke the function before I define it. So here I can actually put this myfunc1 here, and it'll still work. Why? Because JavaScript's going to actually look for this first, put that into memory, and then go back and run my commands line by line. So see, this will work. See, hello world, hello world. But again, it's not the most efficient thing memory-wise, also time-wise as well, because you have to wait for all that time for your JavaScript to go run through your code and load up those memory definitions. It's generally something we've moved away from. Okay, there are still times where you're going to use this function keyword. Okay, but that's sort of the original way you would write functions in JavaScript. Also, whenever you use the function keyword, you're going to end up having a prototype attached to the function. Okay? Because once upon a time, JavaScript did not have classes. Okay, so literally the functions did both. They were classes and functions, which is kind of confusing. Okay, so let's just kind of illustrate this real quick. Let's say I were to create a function called dog. Function dog, and in this function basically say that this dot name equals Sparky. Okay, so see, I can use this basically this function can now be used as a constructor to create objects, which is really weird compared to all the languages. All the languages, usually you have functions being functions and you have classes to create objects. But JavaScript originally had this pattern. And if I wanted to create a new object, I would say, hey, const Sparky equals new dog. And then I'd be able to see, like, hey, it's console.log Sparky's name. Sparky.name. Okay, because this always refers to the instance. So we created a new instance of dog called Sparky. Okay, see, so that did that. But that's not obvious, okay? Especially if you're coming from another language. Using functions to create objects like this is not, or like functions having a dual job of classes, isn't particularly obvious. So later on, what they did is they took this particular functionality and they created a class feature. So that way, the stuff that classes normally do is done in a class, and functions will just do what functions do. So that's what makes this original method of doing functions kind of weird. Okay, I would again probably use classes instead of taking advantage of using the syntax to create constructors, because it's people who are reading your code may be confused because it looks like you're using a class, but it's a function, and it's just weird. Okay, but that's the story with this particular function syntax. It has like two jobs. You can make a function, and it can make a constructor for objects. And the problem with that is that makes when is this referring to what you think it's referring to very confusing. Okay, because it has its own this. That just makes this more tricky. Okay, so let's comment that out. Actually, I'll just delete all that. Then there's the second method. Okay. Method 2 for defining a function. Okay. And here what we do is we do const a name of variable, so this would be my func. Okay. And then we say my func. I still use the function keyword, but notice now I'm assigning the function to a variable. So basically, I'm not giving the function a name, I'm assigning the function itself to a variable. And it would work the same way, console.log, hello world, and then I can invoke the function, my func. Okay. Now this is not hoisted, so you don't have to worry about all that memory issue, because whenever you see this type of pattern, this variable declaration, that doesn't get hoisted. That doesn't get read into memory until it actually shows up in the code. So it's not hoisted, but you still have a prototype. Okay, so you can still turn that into a constructor. You can still be like, this dot name equals, like what I did with dog a second ago. You can still do that. So now, if I were to put my func right before there and try to invoke it before the definition, I should get an error. Let's see, I get an error. Because see, it says my func before initialization. So again, not in this case, you're not hoisted. All the use of the function has to be after the definition of the function. So I have to say it exists before I use it. Okay, which can make your code a little bit snappier, because it's not taking this time to load all these functions into your memory. It's just loading them into your memory as needed. Because again, JavaScript is an interpreted language, so it's read on the fly and run on the fly. It's not a compiled language like Go, C++, Java, C#, where all the code is compiled beforehand. So in that case, you know, there's no real harm in loading up all the functions first before as you compile the code. You know, so keep that in mind. Okay, so that's the second method. And then method number 3, also referred to as arrow functions, which has become sort of the standard, because with this, there's no prototype. It's not hoisted, and there's no prototype. So in that case, you don't have to worry about anything weird with the this keyword. Okay. So this would be like const my func equals, and this is why they call it an arrow function, because you use an arrow after the parentheses and then the curly brackets. Essentially what this means is that this data, the data in the parentheses, is being passed into these instructions. Okay, that's essentially what kind of that syntax kind of represents. Console.log, hello world, and then if I do re-invoke the function, I'm going to do it a few times, my func. Okay. But see, I can use the function, but also it cannot be used as a constructor. So if I were to try to do this, do the whole dog thing, so const dog equals arrow function. I'll just say this dot name equals Sparky again. This won't work. So watch, if I tried to do const Sparky equals a new dog, it's going to throw me an error. Okay? See, dog is not a constructor because arrow functions cannot create object constructors. You have to have the function keyword to do that. Okay, so that should give you that's just the 3 ways that you can create a function and sort of the big differences. My opinion, when it comes to constructing objects, just use classes. Okay, they kind of separated that out into there so that way your code is a lot more obvious as to what you're trying to do. Because when you see the class syntax, it's like, okay, you're creating something to construct objects. And then when you see arrow functions, I know it's a function. I don't have to worry about any this keyword. I don't have to worry about any hoisting. It's just the function. Okay, which is nice. Cool. Now, yeah, we can create a function that just basically delivers instructions. Okay, and that's all well and good. Okay. But what makes functions more fun is being able to have them do multiple things in different situations by being able to pass data into the function. So if I wanted to create like a function that adds numbers, so let's say const add nums, okay? It's in the parentheses where I can define variables to represent data that's going to be passed in. These are referred to as parameters, okay? So we'll just keep it simple, x and y, okay? So these are 2 variables that are being passed in, and I can use them. Okay, we can do console.log, okay, x plus y. Okay, x plus y. So now if I do add nums 5 and 6, 5 gets passed, is the first argument. So 5 is an argument because it's data being passed in. The first argument ends up being assigned to the first parameter. So now x equals 5. 6, the second argument, gets passed into the second parameter, y. So it's going to console log 5 plus 6. So let's try that out. 11. Yay! Okay, so you guys get the idea there. Now what if I didn't put any numbers at all? It's just going to give me undefined because I'm going to have 2 undefined plus undefined. Or not a number, okay, because there's nothing there. So you can't add 2 things that aren't a number because it's undefined plus undefined. Okay, not a number. So what you can do is you can name default values. So I can say by default this is 1, and by default this is 1. So that way if I don't specify, if I don't pass in an argument, it'll default to these values. So now it'll give me 2. Okay? So you can name default values, okay, which is pretty useful for your parameters. Cool. So we can pass data into a function, which is nice. And this is another kind of thing I want to point out about older function methods and other function methods. Because how many arguments can you have? You can pass in as many arguments as you want. So I can pass in 1, 2, 3, okay? But notice, I never defined another parameter after x and y, okay? So even though I pass in 1, that becomes x. I pass in 2, that becomes y. I pass in 3, it just doesn't go anywhere. Okay, I can pass it in. It's just floating around in the ether. So depending on what kind of function syntax you're using, there are 2 different ways to get arguments beyond the ones you define. So what if I have x, I have y. Let's say I want to grab every other argument that's passed in. I can use the spread operator and do something like this. The rest. You can name it whatever you want. But what this does, it takes any other argument that's passed in and puts it into an array. So if I were to do console.log the rest, okay, and let's pass in a whole bunch of arguments, 4, 5, 6, 7, 8, 9, and let's watch what happens. Okay, so see what happened? 1 was passed into x, 2 was passed into y, and then the rest was passed into here. So we have this array of all the other arguments that were passed into the function. So sometimes you might design a function where you want people to be able to pass in lots and lots of data into there. That's one way you can do it. I'll show you some other ways by the time this video is done. Okay, but that's really just for arrow functions. Because if you're using the function keyword, they already have something built into for it. Okay? So let's change this Let me change this with something that uses the function keyword. Because a prototype, this is really like something that prototypes have. And since function keyword gives you a prototype, so this is actually something you can do in class constructors as well, you don't need to define like something that captures the rest. It already exists. There's going to be this object that just automatically exists. You just kind of have to know it exists, called arguments. And arguments contains, it's not really an array. It's an object of, it's a weird object that contains all your other arguments. So if I were to console log it, see you have this object that has all my arguments in it. That's all well and good. That's not super useful as an object like that. So one of the things you may want to do if you decide to go this route is turn it into an array. Okay, so what you would do is you just wrap it, just to show you how I would do that, I would wrap this in an array, use the spread operator, so that way all the values get spread into that array. Okay, if I do that, see now I have, and again, when you're doing it with the function keyword, it's not just the first two it's not just the remaining arguments that get passed in, all the arguments are inside the arguments object. Okay, so keep that in mind. So it's a slight difference, but that's essentially just a slight difference between using the function keyword versus arrow functions. Arrow functions don't have an arguments object, so you have to use the spread operator to capture all those other arguments. Okay, cool. That's a thing. Cool. Now here's the thing. Right now we're just logging all these values. That doesn't really do much for me. I can't do anything with that. So what you want is your function to give you back data that you can then like manipulate and play with, assign to variables. Because right now, if I took add nums, and if I were to assign the result of this function to a variable, so we'll say const result equals add nums. If I were to do this and then console log the result, I'm not going to get anything. I get undefined. Why? Because nothing, this function right now currently gives me nothing back. We're logging it onto the screen, but logging it onto the screen doesn't mean I actually have the data to manipulate. So the way that a function gives data back is you do a return statement. So you do return. This doesn't matter what syntax it is. Return works the same way in all three. So you can return x plus y. So what this will do is return the result of x plus y. So in that case, this function will return, in this case, 1 plus 2, because those are the first two arguments. So that goes, 1 goes into x, 2 goes into y. So returns 3, which gets saved in result, and then we'll console log the number 3. Okay? So see, a function needs to return a value for you to be able to do stuff with it, to store it in a variable, or I could do something like this. I could do add nums plus add nums for 5. So 4 plus 5 is 9. 1 plus 2 is 3. And actually, I'm going to take out all these other arguments and make this a little bit cleaner to look at. So 1 plus 2 is 3. 4 plus 5 is 9. So 3 plus 9 equals 12. So really, the result of this ends up becoming assigned to the variable. But see, now I can actually do those kind of mathematical equations because the function returns a value. So I can say, hey, take the result of this and add it to the result of this, and then assign it to this variable. And again, we'll get like 12. Yep, there we go. So that's how return values work. So to recap, we know how to write functions in 3 ways now. We know how to use parameters and arguments. We know how to set default values for those parameters and arguments. We know how to set a return value for the function. Okay. We've talked about hoisting. We've talked about the arguments object. We've talked about prototypes. So we're doing pretty good. Okay. Now I'm just going to show you some cool tricks with functions. Okay. So the first one I want to talk to you about is destructuring. Okay. Destructuring is really a whole separate feature in JavaScript that allows you to break down arrays and objects. But you can use them in your functions. You can use them going in and going out. So first, let's show you going in. So what we're going to do is destructuring the data that's passed in. Okay, so let me just create a new function. So say const print name. Okay, const print name equals. Okay, and then just And what we really want to do here is we're going to create a person. Okay? We're going to create an object called person. So here's a new object, and we're going to have a name for this person, Alex Merced, and then we have an age, 35. Okay? You've seen my older videos. I've had a birthday since the older videos, so I am now a year older. Okay? Okay, so 35. So what happens is this object, we can pass into the function. So we can use object destructuring. That means I pass in curly brackets into my parameters, and I can pass in what things I want to take from the object that's passed in. The only thing I really want is the name. I don't need the age, so I'm going to just do that. What this means is that if I pass in an object as the first argument, it's just going to pull out the property name and throw away everything else, which is good memory-wise, because then I'm not saving all this extra stuff that I don't need in the memory. I'm only pulling out what I need. It's just those slight little things that make your code a little bit more performant. Okay, so print name, and then all I'm going to do is return, or we'll just console log the name. Okay, cool. So let's show you. Let me actually use the function. So I'm going to print name, and then into the function I'm going to pass in that person object. So what happens? That person gets passed in, and when it sees this syntax, that's the first thing, and it realizes, hey, I'm using object destructuring. So it looks inside the object to see if there's a property called name, and then assigns it to a variable called name. Okay? And then the age variable, since I didn't ask for that, it just throws it away. Okay? Which is nice. Again, the idea is that you're not creating more memory usage than necessary. Okay, cool. So that's destructuring for objects. Now what if I were to do is with an array? So what if I were to change this from an object to an array where the first thing is my name and the second thing is my age? Okay, I can do the same thing. So since the first thing is since I'm passing an array now, I would just use brackets instead. And what's going to happen is that I create variables. So the first thing is the name, and if I want the second thing, I could do age. So then what it'll do is the first thing in the array gets passed into the first variable, and the second thing in the array gets passed on to the next variable, etc. Okay. And again, I do have a whole video on destructuring and all the tricks of destructuring. So there's a video called Destructuring Masterclass. I highly recommend it. It's a really useful feature. Okay, but I only want name, so I can just do this. I'm going to say, hey, just take the first thing, put it in a variable called name, and that does that. So when I do this, see, it still works. Okay, what I'm doing is I'm breaking down the array that I'm passing in. So you could literally just pass all your data as an array or an object, and you'll see functions that do this, where instead of having you pass in a whole bunch of arguments, they'll have you pass in one object that has all the different things that the function needs, or an array that has the things the function needs. You know, so that way it's just, you can actually create, you can do it like this, where I created all that stuff as a separate object. It just makes the code a little bit cleaner. Okay, so that's a thing you can do. Cool. So that's destructuring of parameters, destructuring objects, destructuring, and again you can use defaults too here. So I can be like default, you know, cheese. So basically, if I didn't specify, you know, if the array was empty, the first thing would then be cheese. I could still do that. So that all still works the way you'd think it would. Okay, now let's talk about destructuring the return value. Okay, so let's say I created a function that instead of taking in a person, doesn't take in anything, what it does, we're going to call it return Alex. And all this function does is return, first time we're going to say it returns an array of Alex Merced and my age. What I can do is I can, when that value comes back, I can destructure it right from the get-go. Instead of saving the array in a variable and then using the array, I can do this. I can do const, you use the brackets. Again, the first thing is the name, and the second thing is age. Then I'll say equals return Alex. Okay, So what it does is that when it receives the array from this function, the first thing gets passed into name and the second thing gets passed into age. So now I can actually console log them as separate variables. Okay. And again, because there'll be times you work with functions that pass you these huge objects or huge arrays, and you only need some things from it. So this is a nice way to just pull out what you need. Console.log, name and age. And see, Alex Merced 34. But again, when it's arrays, it's based on the order. So the first variable gets whatever's in the first value of the array. The second variable gets the second value in the array. And again, this is the array the function is returning. So Alex Merced goes into name, 34 goes into age. Now what if I did it as an object? So what if we return an object? So we return name, Alex Merced, and then age 34. So there's an object that we return. I would still do the same thing, except now we put curly brackets around it. Let me get rid of the square brackets. And this would do the same thing. Okay, it would see that it would look at the object that's being returned by the function, look for a name property, assign the value of that name property to this, and then assign the value of the age property to this, and then do the thing. Okay? And the cool thing about that is it allows you to have your function give more than one piece of information, because you can store lots of information in an array or an object, and so your function can give you a lot more than just one value. Because unlike other languages, functions in JavaScript cannot have more than one return value. So if you need to give back more than one thing, you're going to want to return an array or object with the things you need to return. Okay? Other thing I want to point out is reference versus value. So let's say, basically, you want to always think about it this way. Primitives are passed by value. Okay? What's a primitive? Numbers, strings, booleans. Collections are passed by reference. What's a collection? Okay? Objects, arrays, maps, sets. Or really anything that's an object. Because all these things are really, at the end of the day, just objects. Everything in JavaScript is an object. Or anything outside of these things. Okay? So these things are passed by reference. Now let me show you the difference. Okay, let's create a variable, const, or let's just say let num equal 5. I'm going to create a function called const change num equals, we'll pass it in a number. We'll call it the num. Then I collide with the variable name. And what it does, it just says that the num equals 6. And then I will console log this num. And then we'll console log num out, once again outside the original variable. And we actually run the function. So change num 5. Not 5, num. So essentially what's going to happen is that, well, first let's just run the code and we'll walk through it. So notice what happened. We run the function, we pass num, which equals 5, into the variable. We change the variable to 6, and then we log it, we get the 6. But once we're outside of the function, num is still 5. The reason being is that technically when we pass num into the function, it makes a copy of it. So it's no longer 5, the same, it's no longer num. This is still a separate variable. Instead it creates a copy of num called the num that starts with 5. Then we changed it to 6. So in that case, I can't really change the variable on the outside from the inside. Unless I directly access it, unless I did something like this. Num equals 6. But my advice is generally always avoid directly altering variables from the outside inside, because it just makes your code messier and harder to follow for other people to read. Okay, and also can create unintended consequences as far as trying to fix bugs and trying to figure out where the bug's coming from, because you're looking for a variable that was defined 1,000 lines ago for a function that was defined much later. You know, keep your function self-contained. You'll be happy for it. Okay. But let's see what happens if I say it's an object. So let's say let my object equal Alex. Oh, again, objects are key value pairs. So name Alex Merced, comma, age 35. Okay, so let's say here we call this to change name now. What it's going to do is going to change my name. Okay. And we just call this the variable person. And we're going to just say, hey, person dot name equals Hector Merced. Okay, and then we'll console log person inside the function, and we'll console log person outside the function. And we want to make sure we pass in my obj into the function. And that the function is correctly named. Change name. Okay. Node test. Oh, I broke something. Oh, that's right. Person doesn't exist here. It's my obj outside. My obj. There we go. But notice, see, they both changed. So when I pass in an object, even though I'm not changing my obj, I'm changing person, my obj still showed the differences. Because when you pass in an object or an array, you're not passing, it's not making a copy of the value. It's making a copy of the reference. And the reference is just pointing to where the data exists in memory. So in that case, it's still pointing to the same data in memory. So when you make alterations to an object or an array inside your function, it actually does change the original array or function. Okay, so keep that in mind. Okay. So how would you, what if you didn't want to alter the original? Okay, then what you'd probably want to do is say person, right, like in your first line of code, do person equals ... person. So what this does, when you do this, even though you're basically making it equal the same thing, basically you're saying, hey, take the original person, break apart all of its pieces, and put it inside of a new object. So that's essentially what this is saying. But that means it creates a new space in memory and a new address, a new reference. So then technically person no longer refers to the same data that my object refers to. So just doing that special line, I should now no longer have the same problem. And see, now only the original one changes. It doesn't change the original my object. Okay, it would be the same thing if it was an array. If it was an array, except you would just use square brackets instead of curly brackets. So something to keep in mind. Cool. A couple more things. Now we're starting to get into like the extra advanced stuff, the more functional programming style stuff. So first, let me talk about closure. And basic closure is the idea is that you're just taking advantage that things with its same scope can access each other. So, for example, if I go const my func equals, and we're gonna have const in there, make a declaration, const number equals, well, let's say let number equal 5. Let number equal 5. Okay, so we create this number. Now if I were to run the function and then try the console log number, I'm going to get an error. Why? Because even though the function ran and the number gets defined, the minute we get it outside of the curly brackets, the function's done, number gets destroyed. So I'm going to get an error. But what if I want to, but what I can do is, as a trick, is I can return functions that refer to that. Because if I define other functions inside the function, technically they're still within the same set of curly brackets. So they have the same scope, which means they still have access to that number variable. So if I were to return this function, and all this function does is return number. Okay, so and whenever you see syntax like this with the arrow function, so notice I didn't put the curly brackets after. Okay, whenever you don't put the curly brackets after the arrow, that's referred to as an implied return. So basically, all I'm saying is that this function returns this. It's returning the variable number, and that's it. So if you're having a really simple function that's just going to return a value, and that's it, okay, you can just drop the curly brackets so you don't have to write the word return. It just will return whatever expression you put on the other side. Okay? So basically, it's just returning a function that returns a number. Okay. Console.log number. Okay, so now if I take my func, that function returns a function, so I want to save that function somewhere. Okay, so we'll call it getNum because it gets the number. So this function runs and returns this function. This function then gets saved in this variable. So now I can console log the result of getNum, and it will go get that number. And see, now we get the number 5. Okay, very cool. Okay, so that's pretty neat. And that's referred to as closure. So I can create all the functions I want. What if I wanted to make a whole bunch of functions? What if I also wanted to create a function that lets me change the number? I can send it back as an array. So there's a function that the first function gets the number, and I'll create as the second value in the array is another function that takes a value. Okay, and all it does is say, it's not going to return anything, but I'll just say all it does is take number equals value, and that's literally all it does. It just changes the value. Okay, and we have now these two functions that are being passed into, because again, it's only one expression, so even though it's not really a return value, this is still not gonna, it's still going to end up returning nothing. I can still not drop the curly brackets because it's just one expression. The minute you have two expressions, then you need the curly brackets. And same thing with this. I could actually drop the parentheses off of this. If I only have one parameter, I can just drop. If I have no parameters or two or more, then I need the parentheses. But if I just have one parameter, I can do this. So see, this is a very succinct function right there. Cool. So now that returns. So in that case, now this function is returning an array, not a function. But the array has two functions in it. So what I'm going to do is I'm going to use array destructuring to break down those two functions. So the first one's getNum, getNum, and then the second function is, we'll call it setNum because it sets the number. So now what I'm going to do is I'm going to use setNum to change the number to 6, and then we'll still print the number using getNum. And see, I was able to change the number to 6, and I'm literally changing this variable that's here. I technically should not have access to this variable outside of this function. I don't have the scope for it. But by passing functions that were created within the same scope, I can now kind of have access to it. Okay, and that's a neat thing you can do. It's a good way, if you wanted to create data, like let's say you were creating a library or something, and you wanted to create a way that there's data that exists, but people can only change it in very limited numbers of ways. This is kind of one way you can do it. You can sit there, create the data in the function, then the function can return functions that do what you want the user to do and nothing else. So see, I can't do anything other than set the number and get the number. I can't, you know, I'm limited to those two things. Okay. So that's closure. Okay, that's referred to as closure. What I'm doing is, again, I'm taking advantage of the scoping of this parent function that's churning out all these other functions. Okay, next is going to be function currying. Okay, this will be the last topic for this video. Function currying is when you take like imagine you're playing Dungeons and Dragons and you're creating a character, and there might be several steps. You got to choose, like, are they chaotic neutral? What are their stats? So you could just sit there and have one function that says const create car, and then they would have to pass in like the name of the character, the alignment of the character, etc. But then you need to get all that information first and then pass it on to a function. What you can do is you can break your function into multiple steps. Okay, so what I would do here, okay, if I wanted to do this is called function currying. I would say create car equals a function. The first step is to take the name. Okay. And what this function returns is another function that's going to take, then we'll take the alignment. Okay, and then we have a function that takes spells. So literally, this function returns a function which returns a function. That's essentially what this syntax does. Okay, so this function returns, so essentially, this function here is going to return this function, which is going to return this function, which I'm going to complete now. And then when this last function is run, what it does, it's going to return the object with your character. Name equals, well, just name, align. And the cool thing about objects is that if the property name is going to be the same as the variable you're using, so this will just create a property called name using the value whatever name is at that point. Align, same thing. So I don't have to like do anything special. So return, name, align, spells. Okay. So this looks a little weird, but essentially what it's saying, we're just saying this function returns this function, which returns this function. So now, the cool thing is that now you can just pass the data in there as you get it. So I can first, so first we'll say const step 1. So the result of step 1 equals create car Alex Merced. And then technically this returns the first function. So the second function is going to ask for alignment. So const step 2 equals step 1, because we saved the function in step 1, and we have to pass in the alignment, so we'll say lawful good. Okay, and that runs that function, which returns the third function looking for spells. Okay, and then we'll say const car, so our final character, equals step 2 with my spells, and I'll just pass in an array of spells. So fireball, thunderball, or thunderbolt. Okay, and again, so basically this first function passes the name, the second function passes the alignment, and the third function passes spells. But since each of these functions were defined in the previous function, they still have access to the data from the previous function. So this last function, spells, even though it's a separate function, because it was defined by this function, which was defined by this function, has access to align and name. So it has access to all three variables, and it's that last function that creates the object. So now if I console.log car, there we go, Alex Merced with an alignment of lawful good, spells, fireball, and thunderbolt. Okay, so this allows you to chop up something. Instead of having to collect all this data and then do it at the end, you can chop up your function into steps, into multiple functions, and then you just keep passing the data in, and then as you get more data, you pass it into the next function. It's called function currying, because you're chopping it up into pieces and making it a sort of a step-by-step process where each function returns the next step until it's done. Yeah, so that's like the last like super advanced like function technique. So again, this is called function currying. Okay, that's super advanced. So if you appreciate what was going on there, you're in fantastic shape. Yeah, this is pretty much everything you would ever want to know about JavaScript functions. So hopefully you guys enjoyed that. And then after that, it's just basically just making functions to do the things you need them to do. You have a great one. Ciao, and have a good one.